Hi, this is Peter with CalcBook, and today we're going to be continuing our weld design series by looking at double line welds. So pretty similar to the other weld designs that we've been looking at, right? It's going to be in accordance with AISC Specification Chapter J. We're going to be using the Blodgett method, right? So that means that we treat the weld as a line with no throat. And we can always evaluate with CalcBook against the 6 degrees of freedom. So FX, FY, FZ, which is coming out of the page, and then MX, MY, and MZ, which is torsion. So let's take a look at our problem statement for today. Let's assume that we have a stair tread that is supported by 3/8 thick steel connection plates on either side. The plates are 3/8 inches thick, 6 inches by 6 inches, and it's an A36 plate. We're going to be using the E70 electrodes. And our loading, if we blow up just one of those connections that are on the side, right, we're going to assume that the loading from the stair tread is supported at the end there of that plate. And we assume that we have a fillet weld on both sides of the plate there, top and bottom. And we have a dead load of 0.2 kips or 200 pounds, and then a live load of 0.8 kips or 800 pounds. And that is going to be at the end of the plate, which is 6 inches away from the connection face. So if we convert that into our loading for CalcBook, right, we need to just kind of move some coordinates around and then also get our moments. So we have loading in the X direction of 0.2 kips and then also 0.8 kips for dead and live. And then we have the moment about the Y-axis for dead load of 0.1 kip foot and then for live load of 0.4 kip foot. So let's go ahead and open up CalcBook and we'll get started on the design. Okay, we've got CalcBook open now, so we go ahead and click into either the 15th or the 16th. The calculations are virtually the same. There's just a little bit of a difference on how parts of the equation are formulated regarding the angle of the weld against the angle of the force there. So for our purposes, it doesn't really matter, so we're going to go ahead and use the 16th edition. We will click into our connection design, and then we'll scroll down and click on our double line weld design. Okay, so now we can go ahead and enter in some information about the weld. So the first thing we'll do is enter in the height of the weld, which is going to be 6 inches, right? Because that's the amount of contact surface there is between the plate and the stringer, right? So that's where the weld is. That's the length of the weld, essentially. And then the width of the weld is going to be basically the plate width, right, or the plate thickness, so 3/8 plate, and then we're going to add half of the weld. So that means 3/8 plus half of a 1/4 inch weld is going to give us a total B, or width, between the welds here of 0.5 inches. And that comes from basically the distance to sort of the centroid of the weld. And there's a good AISC journal article on this, and I'll post a link to that in the description below. But that's basically what we want to use, the thickness of the plate plus half of the weld, and that will get us our 0.5 inches. We're going to use a 1/4 inch fillet weld, so we'll leave that as is, and then we're going to use our 70 KSI strength there for the filler metal. Okay, so then we can go over to our demands. We're going to go ahead and use the AISC 716 load combinations. And remember, we've already sort of transformed our loads into the CalcBook coordinate system here. So we're going to go ahead and use our FX of dead load of 0.2 kips, our FX of live load of 0.8 kips, and then we're going to scroll down and apply our moment about the Y-axis. For dead load is going to be 0.1 kip foot, and for live load is going to be 0.4 kip foot. Okay, so now we've got all that information entered. We can take a look at our calculations here. So let's go ahead and look at the demand. So we get our section properties of the weld group, so our total length, our elastic section modulus, our torsional constant. Then we want to go through and check the weld stress due to each load component. So we have the shear per inch due to FX, right? The shear per inch of FY, which is 0 because we don't have any load in that direction. And then we can go down to our MY here, our shear per inch due to that moment. And then we combine the two, right? And then we take the square root sum of the squares to get our total shear per inch for this weld condition, which is going to give us 3.04 kips per inch. Once we have that, we can go to the capacity side, right? And we just check the capacity of the weld using our Chapter J calculations. And this KDS factor is that strength increase factor, the directional strength increase factor. This is what is a little bit different between the 15th and the 16th edition. For the purpose of this calculation, we take it to be 1.0. And then we calculate our nominal shear capacity per linear inch, and then our design weld shear strength of 5.57 kips per inch. So our capacity is sufficient to resist the loading, so this calculation is good to go. So that is a double line weld in CalcBook. We hope you enjoyed the video. If you would like a 25% discount off your first month subscription of CalcBook, you can use the discount code YTCB2024, and we'll see you next time.